Hello, hello everyone. It's good to see you again. How have you been?
Good morning, mister.
Morning. Bueno, muchachos, antes de comenzar la clase, pues es mi deber como su maestro guía, pues no en particular, sino que en un plano general, ¿verdad? Tratar de llamarles la atención en un plano general. Obviamente no lo digo para las personas que cumplen, sino que hablo en términos general. Muchachos, tenemos que ser un poquito más responsables al acudir a las clases de los profesores, porque sí estoy recibiendo bastantes reportes, por no decir quejas, de los maestros que ustedes, muchos de ustedes, no digo que todos, pero muchos de ustedes no están asistiendo a todas las clases, sino que están siendo selectivos. ¿Sí, Gustavo?
Mister, en la primera clase siempre llego tarde porque yo recibo clases en el trabajo de mi mamá y queda un poquito lejos.
Ah, ok.
Más el tráfico.
Bueno, pero por lo menos llega. Pero
Sí.
hay muchos de que ni siquiera, pues, integran. Entonces, muchachos, por favor, como le digo, no lo digo por alguien en particular, sino que lo estoy haciendo en forma general, ¿verdad? Tenemos que ser un cachito más responsable con los horarios, porque el profesor o la profesora al no estar, pues directamente tiene todo el derecho de penalizarlos en un trabajo de clase, alguna prueba o algo que se desarrolle. Y usted no se presenta a clase por A, B o C o D o factor y no hay una excusa que lo justifique, ni modo, pierde sus puntos, ¿verdad? Entonces, para que evitemos tener ese tipo de problemas, por favor, tratemos de ser un poquito más puntuales, ¿verdad? Y si hay algún inconveniente que se esté suscitando, puede comunicárselo en este caso, a su servidor o directamente al profesor diciendo, mire, profesor, pasó esto y esto y esto, y esto, me voy a conectar unos minutos tarde o por esta razón, tal cosa, pero que tenga ¿cómo es la palabra? Justificación para el maestro. Pero que el maestro empiece la clase y solo hayan pocos alumnos, por ejemplo, en mi caso, ahorita tengo 19 estudiantes. Tengo a Lorna, déjenme, vamos a hacer una pista en galería. Aquí tengo a Gustavo, Luis, Julio, Mili, Alejandra, David, Natalia, Sofía, las dos Sofías, Lorna, bueno, Lorna, creo que está Lorna porque solo miro el nombre, pero no veo las
Aquí estoy,
cámaras.
mister.
Ah, bueno. Turn on the camera, please. José Burgos, Diego Morales, Aarón, no sé si está Aarón, no sé si está Manuel, María José, no sé si están presentes, muchachos. ¿Hay algún problema con sus cámaras? Perdón. Entonces, bueno, ya pues ya las licencias son 20, 21. Entonces, es necesario que estemos en clase, ¿verdad? Hay cualquier problema que se suscite, favor, comuníquemelo o directamente con el profesor, o sea, la facilidad que usted tenga de momento para poderle ayudar y así, pues, constatar cuál es la situación. ¿De acuerdo? Bueno, entonces eso era antes que tenía que decir antes de comenzar. Bueno, entonces vamos a continuar con la clase. Obvio, eso no es de ustedes, eso es de octavo grado. No sé si recuerdan ese temita de las áreas superficiales, que es bien bonito el año pasado que lo vimos. Por cierto, un anuncio, ya lo que son las guías de estudio ya están en la plataforma de EduBox. Entonces, cuando ustedes gusten, pueden descargarla y pueden comenzar a practicar. Ahí va a encontrar todo lo necesario para el examen bimestral, ¿verdad? Entonces, durante el transcurso de la clase y en el desarrollo de la misma, si usted llega a tener alguna duda, me lo hace saber, ¿ok? Bueno, voy a borrar la pizarra y por los momentos voy a copiar de nuevo el ejercicio que comenzamos el día de ayer, ¿de acuerdo? Entonces, para poder aclarar cómo son los eventos dependientes e independientes. Y de hecho, como creo que fue Gustavo que dijo ayer, que el evento era dependiente y la respuesta es correcta. Sí, sí era dependiente porque una vez que la máquina dispensadora se come un chicle, no es que lo va a reemplazar, sino que una vez que se lo come, se lo comió y punto. ya no vuelve el chicken. Entonces ya estamos hablando que es un evento dependiente. Solo déjenme buscar el ejercicio, ¿verdad? Un 16. Déjenme ver cuál era. A gumball machine, right? Bueno, lo voy a leer. De todas formas, ustedes ya lo tienen copiado. Solo es para continuar con el ejercicio y no demorarnos mucho, ¿verdad? Entonces, en este ejercicio nos decía, a gumball machine has 21 gumballs, red gumballs. I'm going to copy that data. 21 red gumballs. 21 red gumballs. At the same time, 24 yellow gumballs. 24 yellow gumballs. Okay. And finally, the problem says we're supposed to have 15 blue gumballs. Okay. 50 blue gumballs. We conclude that quantity of gumballs that that's supposed to have. The machine that was around 60 gumballs, right? 60 gumballs. Okay, combining between red, yellow, and blue. Okay, and we have a few questions. The first question is, what is the probability? That question, I'm going to copy that one, okay? Letter A. What is the probability? What is the probability that the gumball machine that the gumball machine that the gumball machine dispense 2 red gumballs dispense 2 red gumballs in a row. Okay. Once again, what is the probability the gumball dispenses 2 red gumballs in a row? All right. Remember, yesterday we were talking about this is the dependent event because the machine is going to dispense 2 red gumballs. So we cannot replace the gumballs at the moment we're going to do in that situation. What will be the big deal in this case? Remember the formula from the probability. Probability that will be equal to the probability A times the probability even A or B. Okay. In this case, we just want to calculate what will be the probability to this machine dispense 2 red gumballs. What is the situation? The first one, in the first one, we have to apply the probability we're going to take the red gumball. What is the situation? Remember, we have to obtain the total number of events divided by the total quantity of events that we're supposed to have. I mean, how many red gumballs do we have in this machine? We have 21 red gumballs. Okay, 21 red gumballs. And the entire bag, we have obviously 60 gumballs because this is the entire machine. They're going to take it at the first try. All right. So in this case, this is going to, in the second part, this is going to be a little bit complicated because at the moment, I'm going to take the second red gumball because this is the probability that we're supposed to have. In the back, in the denominator, I won't have 60 gumballs anymore. How many gumballs are going to have if I take one already?
59.
59 in the denominator. Okay, in the denominator. However, because think about it. Because I'm going to take once again a red gumbo, I have a question for you. How many red gumbos do we have in this time, in this occasion?
20.
20. Perfect. Because at the beginning, we're focused in the quantity of, in the first try, we have originally 21 red gumbos and we have 60 gumbos. Okay. And the second one, because I'm going to take a second red one, we are missing the first one that I'm taking, but I won't have any more 21 red gumbos because I'm eating one at the first try. For that reason, I'm going to have 20. Did you understand the point? Did you understand the point why is 20 over 59?
because you already taken one red combo.
Exactly. And a difference with the entire problems, in the entire problems, I'm not subtracting the numerator because we're talking about different color. Because this time I'm talking about the same color, I'm subtracting 1 unit in the numerator and 1 unit in the denominator. The rest of the people, did you understand the idea? Okay,
Yes.
perfect. So if you wish, before to multiply this situation, we can simplify the fraction as soon as we can. For example, the first fraction, we have 21 over 60. That will be 7 over 20 in the first one, because it can be divided by 3. 7 over 20 multiplying by 20 over 59. And if you see at the moment we are simplifying this fraction, we can perfectly cancel this number 20 with this number 20, and this result, or the result, will be 7 over 59. And this is going to be the answer, at least the answer of the first question. What is the probability that the gumball machine dispense 2 red gumballs in a row? Well, 7 over 59. You can leave the answer in fractions. We can leave the answer in decimal numbers, or if you wish, in percentage. All right, that was the first question, the letter A. Now I'm going to copy the letter B. In the letter B, mention what is the probability that the gumball machine, what is the probability that the gumball machine, sorry, that the gumball machine dispense a red gumball a red gumball, comma, then a yellow gumball, then a yellow gumball. Interesting, right? What is the probability that the gumball machine dispense a red gumball, then a yellow gumball? What kind of events would be this situation? Dependent or independent? Think about it. Think the gumball machine. The gumball machine will replace by himself every time that we're going to eating their candies?
No,
No, for that reason, it still continue doing that in the that will be a dependent event, right? Because the machine doesn't replace that every time that we're going to eat any candies. Just focus in that situation, okay? So the formula, same way with the formula. Probability, that will be the probability A times the probability of the event A or B, okay? So the first event, we're going to take a red gumball, right? So we're going to provide or continue with the same situation. Remember, how many red gumballs do we have? We have 21. How many gumballs are in the back or the machine? Will be 60. Okay. Now, because at the moment I'm going to take the yellow gumball, How many gumbos do we have in the entire machine right now?
59.
59, right? 59, because I'm eating one gumbo. And I have a question for you. How many yellow gumbos I have to put in this case?
24.
24. And if you see, in this situation, I'm not subtracting. Once again, I'm not subtracting this time with the unit in the denominator. Would you like to tell me why this time I didn't subtract one unit in the numerator?
Because you took a red gumbo and not a yellow gumbo.
Exactly, because at the beginning, we are taking a red gumbo and we are talking about a different gumbo. So we have the entire 24 gumbos in that situation. That's why I'm not subtracting the numerator, but I'm subtracting the denominator because in the entire 60 gumbos that's supposed to have the machine, we are missing the number one because this machine gumbo machine doesn't replace that situation. Well, once again, remember, every time that we can simplify this fraction, we can do it also. Remember, 21 over 60, that will be the same thing that we have 27 over 20, okay? And this, when 7 over 20 can be multiplied by 24 over 59. And if you see, we can multiply this fraction. If you wish, you can simplify them. At the end, we're going to get the same result. Okay, so 7 over 20, there will be, oh, sorry, 7 over 20 multiplied by 24 over 59. And the answer will be 42 over 295. Okay, 42 over, sorry, 42 over 295. Okay, that was in the letter B. Just to clarify, dependent even, if you really want to apply directly this kind of problems, you're going to identify an easier way because at the moment we to take one singular issue and it doesn't matter, we're talking about candies, we're talking about bowls, we're talking about how to say that, pens, forks, knives. If we are not replacing, this is going to be dependent even. If you are replacing that situation, that will be independent even. In simple melody words. And obviously, we're talking about the complex machine. The problem never says, it won't be replaced. But if you're using the common sense, the Gumball's machines doesn't replace the candies by himself. Obviously, the order that Gumball machines and some period of time, they're going to open the machine, bring their money, and after that, we'll refill once again the Gumball machine with their candies, obviously. Okay. Now, the letter C, the question C, the letter C. Okay. In the letter C, the problem says, what is the probability that the gumball machine dispense? What is the probability that gumball machine dispense the gumball machine dispense a red gumball, comma, then a blue gumball. If you see, third question, probability that dispense a red gumball and then a blue gumball. What we have to do? If you want to copy the formula, you can do it again. This is the list of preoccupations or the problems. Probably A times probably A or B. Okay. So once again, Now, but first of all, we need to take a red combo. Same happen. 21 over 60. And what will be the formula from the second probability? What will be the fraction? Any idea? What will be the second fraction?
15 over 59.
Exactly, 15 over 59. Perfect. Because we have 15 blue gumbos, but this time we're going to have only 59. Excellent. Perfect. So remember, 21 over 60, if you can simplify that fraction first of all, you can do it also. 7 over 20 multiplying by 15 over 59. And at the end, we can multiply that fraction. Okay. So the final result will be 7 over 20 multiplied by 15 over 59. And the answer will be 21 over 236. 21 over 236. And this is going to be the solution set of the problem. That was the problem number 1 or number 2. I don't remember. That was the problem number 2 yesterday, right? Or the first one. Well, it doesn't matter the order, but this is going to be the solution set of this situation. Questions?
No, mister.
Okay, then. Now we're going to apply another example. I'm going to write example number 2. I'm going to use the blue marker because I don't want to obtain a mess with the same color. Okay. In the problem number 2, we're going to change the mechanical of the problems. And now we are not talking about balls. We are not talking about candies. Now we're talking about people. In this case, the problem says, in art class, in art class, o en la clase de arte, consists of 8 boys, consist of 8 boys, 8 boys, and 10 girls. And 10 girls. Period. And our class consists of 8 boys and 10 girls. Continue with the situation. The teacher randomly chooses. The teacher randomly chooses 3 students to present their work. 3 students to present the work. The work. I said the homework, but the brother mentioned their work, not the work. Their work is their work. Okay, this is the question. Find the probability. Find the probability that all 3 of the students all of the 3 students Okay. Chosen are girls. Chosen, yeah. Excellent. Chosen are girls. And that's it. This is the question. In our class consists 8 boys and 10 girls. The teacher randomly chooses 3 students to present their work. The question is, find the probability that all of the 3 students chosen are girls. All right. First of all, before to do that, remember that we have to find out the quantity, the total number of students. A number of students. According for this problem, the number of students, we're supposed to have 8 boys and obviously 10 girls. For that reason, the entire number of students that will be 18. All right, 18 students. This is the quantity is 18 students with the distribution 8 boys and 10 girls. I have a question for you. Is this independent or dependent event? What do you think? Because this is a question. This is the first question that you have to imagine every time that we start a problem. Imagine it could be dependent or independent event.
Dependent,
Dependent. Why is dependent?
because when one student goes to present their work,
Mhm.
you're gonna subtract that from the amount of total students, and because he's not gonna present his work again or his or
Hey,
her work.
excellent reasoning. I couldn't explain the a better reasoning than that. And that's the main reason, because the student, one person, for example, if we have Sophia, we have Millie, we have Mariana, and if I'm asking for their math homework, I won't asking them again the same homework, right? For that reason, you're going to subtract the any situations. Okay, what will be the formula that we're supposed to apply? Simple formula to apply, that will be probably even 8, okay? Or probably equals probably A times probability A or B, okay? Or sometimes A or B, or sometimes A or C, depending what will be the situation. Okay, at the beginning, chon, 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 the first one, how we can apply the formula for probability at the beginning. Focus in the first girl. What will be the formula or the fraction of this probability? Mhm. Remember the first one. What will be the fraction that we're supposed to use? Remember,
3 over 80.
excuse me,
3 over 80.
3 students over 18. Okay, could be a nice, but remember, we're supposed to choose 3 students, and that's supposed to be these 3 students, that's supposed to be the probability, that's supposed to be girls, right? Yeah, 3 over 80. But remember, at the beginning, how many girls do we have at the beginning?
10.
10, right? So remember, focus at the first try. We are starting the, how to say that, the ruffle, as Amanda was speaking. And I'm going to moving the table, and I'm going to obtain the first name, okay? So at the beginning, we have to obtain the probability for the 10 girls. What will be the first one? Because at the beginning, we have 10 girls. Understood? Did you understand the point or no? Mhm.
Yes, mister.
All right, so in the first one, I'm going to use 10 girls, right? Because divided by 18 students, because this is going to be the first probability that will be the first girl. Okay, so let's focus in the second one. What will be the probability in the second try? Because remember, you're taking the first name, Juana. Okay, girl, girl, that way. Excellent. Now, when I'm going to take the second name, how many girls we're going to have at the moment? I'm going to take the second name. How many girls?
9.
9, right? Exactly. 9. 9. 9 over what? How many students do we have at this moment? How
15.
many? 15 or 17? Remember, at the beginning, we're going to start with the raffle, okay? At the beginning, we're going to take the first row. We have 10 girls, 18 students. And the first one, the winner was Millie. Millie was the first one. Okay, then. Now, in the second try, okay, remember, focus. In the second try, I want to have not 10 girls anymore. I want to have only 9 girls because they present their work, right? This is perfectly clear. But how many students are going to have in the second try? We will be 18, 17, 16. Tell me. In the second try, remember, only Miller have the chosen one. So we're going to have only 17 students. Okay, because this is going to be in the second try. Did you understand the point of this for or no? This is the second try. Okay, in the second try, the winner was Lorna. Lorna was the winner. He's supposed to present their homework, okay? And now in the third try, because there will be, find a probability that how all the 3 students chosen are girls. I never said only 2 brothers. It could be 3, it could be 4, depending on the case. So the third try, how will be the equation? How many girls are we going to have at the beginning of the third try?
8.
8, perfect. 8, right? 8. And would you like to tell me how many students do we have at the third try, at the beginning of the third try?
16.
16, perfect. Because if you see, we have 18 students and we are subtract the 3 girls, the remaining students will be 16. And we have the resolution. At the beginning, in the first try, after the first try, and after the second try. This is the way how we can represent this probability. Understood? Understood? Okay.
Yes.
Now, if you wish, we can simplify the fractions. For example, that will be easier for us simplify before to multiply. Well, as soon as we can. In the first one will be 5 over 9. Okay. 5 over 9. In this case, there's nothing we can do. 9 over 17 and a over 16 for obviously reasons that will be 1/2. All right, 1/2. What we have to do, if you see, we can perfectly cancel the number 9, this 9 over here with the number 9 over here, and we can multiply 5 times 1 will be 5. Hey, and 17 times 2, that will be 34. Hey, and that's it. That's all that we have to do in this case. And this is how we can solve the problem. Remember, guys, I never said only we had 2 products. We had 3 products, 4 products, depending what the problem states. All right. Did you understand the problem?
Yes, mister.
Okay. Let's see. We have some time to solve another one. Yeah. This is going to be, let me see what we got. Yeah, this is going to be easier for us. Okay. Number 3. Da, 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 da. In the problem number 3 says, a CD player has 2 settings. A CD player has 2 settings. A CD player has 2 settings. Comma, random and shuffle. Random and shuffle. I think this is the right pronunciation. I'm not pretty sure if that's right, the pronunciation, but I'm going to figure it out, find out the shuffle. But I think this is the right pronunciation. Okay. The shuffle setting plays, the shuffle settings, the shuffle setting plays, the shuffle setting plays all the songs of the city, all the songs of the city of the city only once. Only once. Only once. In random order. In random order. In random order. Period. Okay. The random settings select songs the random setting selects song randomly from the series. Randomly from the CD. But does not keep track but what? Does not keep track does not keep track of which songs have already been played. Have already been played. Okay. And we have questions. Letter A. You play ACD using the random setting. Letter A. Again, you play ACD using a random setting. You play the CD using the random setting. Okay. Are the select period? Are the selections of the first two sounds that are player? Period. Are the selections? Are the selections of the first two sounds of the first two sounds that are played?
Mister,
Mhm.
it's time.
It is time. Okay, just let me finish the first question. Independent or dependent even? Well, I know it is time. Okay, we're going to finish up to this part. And I see two students raising their hand. Yes, Gustavo, I think it was one, and Luis with another one, right?
It was Manuel.
Oh, okay then. All right, guys. We're going to leave onto this problem. Tomorrow, we're going to continue solving that one. All right. Thank you so much for your attendance. Have a great and wonderful day. See you
Bye,
tomorrow.
mister.
If God wills. See ya. Take care of yourself. Bye.
Bye, Mr.